Good morning, this is Kasturi Day. Today I'm going to discuss the chemistry chapter, that is hydrogen, according to ICSE syllabus class 8. So I'll start today with Bosch process. Okay, this is a process by which hydrogen is prepared on a large scale basis. Okay, so the steps in this process are: first, the steam is passed over hot coke. Okay, coke, that is carbon. So hot coke, that is hot carbon, over which the steam is passed at 1000 degrees centigrade. Okay, in a furnace, or you can say converters. Okay, that furnace is known as converter, where this steam is passed over hot coke and water gas is produced. Water gas consists of carbon monoxide and hydrogen. Okay, here heat is absorbed, that is, it is endothermic reaction. Okay, now the water gas is mixed with excess of the steam and it is passed over a catalyst, which is ferric oxide. Okay, it is ferric oxide, Fe2O3, ferric oxide, and a promoter here it is used, that is chromium oxide, chromium dioxide. Okay, so chromium oxide is here used as a promoter, and iron oxide, that is ferric oxide, is used as a catalyst. And this water gas, which is produced when steam is passed over hot coke at 1000 degrees centigrade, this water gas is formed, and this water gas is mixed with excess of steam in presence of catalyst Fe2O3 and a promoter chromium oxide. Okay, at 450 degrees centigrade, and then carbon dioxide and hydrogen is formed, liberating a large amount of heat. That's This reaction is exothermic. The first reaction, when the water gas was formed, that was an endothermic reaction. But the second reaction, when the water gas reacts with steam, okay, with excess of steam, then hydrogen is produced, and the hydrogen is produced, that time the reaction becomes exothermic reaction. So the products in this reaction are hydrogen, carbon dioxide, and some unreacted carbon monoxide. Okay, now hydrogen is separated from carbon dioxide by passing the mixture through water under pressure, in which carbon dioxide get dissolved, leaving behind hydrogen. So how is hydrogen separated from this carbon dioxide? By passing these two gases, when they are produced, they are passed through a mixture underwater, through water under pressure. Okay, this hydrogen and carbon dioxide mixture, that is passed through water under pressure. Carbon dioxide gets dissolved in this water and hydrogen is left behind. Now that is how the hydrogen is separated from this in this process. Okay, now carbon dioxide can also be separated. See, carbon dioxide get dissolved in water. Now this carbon dioxide is again separated by passing this carbon dioxide. Okay, one way of separating carbon dioxide from hydrogen is passing through water, okay, under pressure. Another way is if we pass this mixture, that is a mixture of hydrogen and carbon dioxide, by passing it through KOH, caustic potash solution. Okay, caustic potash solution or KOH solution, then also carbon dioxide get absorbed with KOH, forming K2CO3 and water, and hydrogen gets separated. Okay, now to separate the carbon monoxide, which has been I told you that the product carbon monoxide is some unreacted carbon monoxide are being also produced in the reaction. So that carbon monoxide, to separate that carbon monoxide, the gaseous mixture, that is hydrogen, carbon dioxide, and the unreacted carbon monoxide, that is passed through ammonical cuprous chloride, okay, in which the carbon monoxide dissolves, leaving behind hydrogen. Okay, so ammonical cuprous chloride is CuCl plus this CO, that is carbon monoxide, and water, because it's a solution. So it forms additional product, it's an addition product. So CuCl dot CO dot 2H2O, and this carbon monoxide get absorbed in this, and hydrogen is separated. So first, what do we do in this Bosch process? First, we pass steam over hot coke at around 1000 degrees centigrade in a furnace known as converter. Okay. Now the water gas is formed. What is water gas? Water gas is carbon monoxide and hydrogen. Okay. Now this is an endothermic reaction because it absorbs heat to complete the reaction. Next, this water gas is mixed with excess of steam and it is passed over a catalyst known as ferric oxide, that is Fe2O3, and a promoter is also used to enhance the working of the catalyst, that is chromium oxide. Okay, that is used, okay, as a promoter at around 450 degrees centigrade temperature. Okay, now what happens? Carbon dioxide, hydrogen, and some unreacted carbon monoxide along with some heat is produced. Okay, so this reaction is an exothermic reaction. Now we need to separate hydrogen because we are preparing hydrogen on a large scale basis. So hydrogen has to be separated from these two gases. One is carbon dioxide, another is carbon monoxide. So now we need to pass this mixture through water under pressure, where carbon dioxide gets dissolved and leaves behind the hydrogen. Okay, now and some unreacted carbon monoxide is still left. Now what do? We can also pass this mixture, that is hydrogen, carbon dioxide and carbon monoxide, through KOH solution, caustic potash solution. Then this caustic potash will absorb carbon dioxide, forming K2CO3, potassium carbonate and water, and the hydrogen will be left behind along with certain unreacted carbon monoxide. This to separate now from carbon monoxide, separate hydrogen from carbon monoxide, we pass the mixture of hydrogen and carbon monoxide is still left. Okay, so carbon dioxide has been separated out. What is left? Hydrogen and carbon monoxide. Now this mixture is passed through ammoniacal cuprous chloride, where carbon monoxide gets dissolved, forming an addition product, that is CuCl CO2H2O, and hydrogen leaves behind. Okay, now physical properties of hydrogen gas. First is nature. Nature is its pure hydrogen is colorless, odorless and tasteless gas. It is non-poisonous in nature. Okay, second is solubility. It is sparingly soluble in water. Okay, that's why it can be passed through water without being dissolved. So it is sparingly soluble in water. 1 liter of water dissolves only about 20 ml of hydrogen gas at ordinary temperature and pressure. Okay, now liquefaction. It cannot be liquefied easily. At around minus 240 degrees centigrade and 20 atmospheric pressure, it can be liquefied into a colorless liquid. Density, it is the lightest of all the gases, and air is 14.4 times heavier than hydrogen. Okay, so air, this hydrogen can be collected over air also, because air will settle down and hydrogen will be in the upper portion because it's a light gas than the air. Next we come to some chemical properties. Now this action on litmus. It is neutral to litmus. This hydrogen gas is neutral to litmus. That is, it does not change blue litmus paper red, moist blue litmus paper red, or moist red litmus paper blue. It is neutral to litmus, does not change color of the litmus. Combustibility, it is combustible in nature. That is, it burns. This pure hydrogen burns in air silently with a pale blue flame. But ordinary hydrogen burns in air with a pop sound. Because why this happens? Because there are some impurities which are present in this ordinary hydrogen. That's why it burns with a pop sound. That's why this pop sound is a characteristic sound of hydrogen, and this sound is used for testing hydrogen. Okay, it is a non-supporter of burning. It itself is a combustible, itself is combustible gas, but it's non-supporter of it burning. That is, it does not support burning. Then reaction of hydrogen with some non-metals. First is action with oxygen. It burns in oxygen with a blue flame to form steam, which condenses to form water. How we'll say that whether this steam is water or not. Okay, so this is an exothermic reaction. The released energy is captured to propel some rockets. So see if this condensed water, if this steam is water or not, we will see. We will test this by if we put this water on anhydrous copper sulfate, white anhydrous copper sulfate crystals. It will change into blue hydrated copper sulfate crystals. Then it will prove that the substance, the product which has been formed after burning in oxygen, it will that will be water. Okay, now this reaction is exothermic and the released energy is captured to propel some rockets where liquid hydrogen and liquid oxygen is being used, that is LOX you can say. Okay, that is stored in the rocket tanks. Okay, and note, mixture of this hydrogen and oxygen is called detonating mixture. Okay, now second is action with chlorine. In diffuse sunlight, hydrogen combines with equal volumes of greenish yellow chlorine gas to form a colorless hydrogen chloride gas. Okay, now action with nitrogen. In presence of iron as a catalyst at 450 degrees centigrade temperature and 200 atmospheric pressure, hydrogen reacts with nitrogen in the ratio of 3:1 to produce ammonia, or you can say nitrogen trihydride. Okay, or trihydride, trihydrogen nitride you can say, or ammonia. Okay, next is in presence of, that is two things are there. One is iron as a catalyst, molybdenum as a promoter, 200 to 900 atmospheric pressure and 450 degree centigrade. Now action with sulfur. When hydrogen gas is passed over boiling sulfur, hydrogen sulfide gas is formed. How can you say that is hydrogen sulfide? Because it gives a smell of rotten eggs. Okay, now reaction with metals. In hydrogen reacts with hot metals to form their hydrides. Okay, like most of the metal hydrides are unstable in nature. Okay, they cannot stay stable. So like that, for example, see Na, that is 2 sodium, Na plus H2, that is sodium plus hydrogen gives us sodium hydride. Calcium plus hydrogen gives us calcium hydride. It acts as a reducing agent when hydrogen gas is passed over hot metallic oxides, minded, it reduces them to their corresponding metals. Okay, so that is cuprous. For example, cuprous oxide, CuO, with hydrogen forms copper and water. Then again, lead monoxide with hydrogen forms lead and water. So hydrogen separates this metal from their metal oxides. Okay, the oxides of highly reactive metals like sodium, potassium, aluminium, calcium and magnesium do not get reduced by their respective metals into their respective metals because they are high above the metal activity series and hydrogen is much lower. Okay, so see in this when lead oxide, hydrogen is passed over lead oxide, then hydrogen comes out, excess of hydrogen starts burning. Okay, see, the test for hydrogen is it burns in air to form a characteristic pop sound. Another is it burns in air to form in air on oxygen to form a pale blue flame, and water is formed, and that can be tested by sprinkling it with white copper sulfate crystals, change into blue hydrated copper sulfate crystals. Okay, so this is the end of the this is the today's end. Okay, I'll continue with the rest of the chapter in my next video. Please go through this and do subscribe to get the notification of my next video. Okay, and share the video with your friends and colleagues. Okay, thank you for watching.